So I'm going over the review for the test. On number 1, it wants me to solve the triangle and round the lengths to the nearest tenth and the angle measures to the nearest degree. So if I look at what this triangle gives me, it gives me an angle, and a side. So because I have 2 angles, I'm going to start off by finding the third angle. I do that by taking 180 and subtracting the 2 angles that I do have. This gives me 35. I'm also going to write my answers over off to the side so it's just easier for me to see. Then I need to use the law of sines to find my missing angles. Remember, law of sines is this ratio where I take the side length over the sine of the angle and I can set it equal to any of the 3 sides or angles. Okay. So I am going to start off with, I have my b value, so I'm going to use that one. And then I will do a, just because it comes first. What I want to do is I want to multiply both sides by sine 50 so I get it over and I isolate my variable. So this gives me a equals 3 sine 50 over sine 35. Then I want to take that and type it into my calculator. I also want to make sure my calculator is in degrees. If I have a new calculator, it'll say it up here. If I have an old calculator, I go to mode and the word degree will be highlighted. Okay. Then I type this in. When I type in the 50, I want to make sure I close the parentheses, otherwise it'll come up with an error when I try and type in the bottom sign. And this gives me 4.00, so I was solving for little a. It is 4. Okay. I'm going to do the same thing to solve for c. So I'm going to have 3 over sine 35 equals c over sine 95. Then I want to get the letter c by itself, so I'm going to multiply both sides by sine 95. And I get c equals 3 sine 95 over sine 35. And that gets me 5.2. Okay. This one wants me to solve for the triangle, but I have to draw the triangle myself. B is 49, C is 115, little b is 49, and I don't know anything else. So I'm going to start off by solving for my angle A. I have 180 minus 115 minus 49 equals 16. And I'll label this on my triangle. So then what I want to do next is I want to solve for my missing side lengths. I have my B angle and my B side, so I'm going to start off with that. I have 49 sine of 49 equals, I'll do A. I don't know my A side length, but I know my A angle length, or measure. Then, just like before, I want to get rid of the sine 16 on the denominator. And I end up with A equals 49 sine 16 over sine 49. I want to type that in. And this gives me 17.89, so 17.9 if I'm rounding to 1 decimal place. I'm going to go ahead and do the same thing with the C side length. I have 49 sine 49 equals C sine 115. Then for this one, I want to get C alone, so I multiply by sine 115 on both sides. gives me C equals 49 sine 115 over sine 49. And I get 58.8. Okay. This one, need to draw the triangle again. And little a. Okay. So this one I'm going to solve for my angle for B. I have 188 minus 11.2 minus 131.6, which gives me 37.2. Okay. Then write this on my triangle. I'm going to use my A pair to solve for the other one. So I have 83.2 over sine 11.2 equals little b over sine 37.2. To get my little b alone, I need to multiply by sine 37.2. Then I get b equals 83.2 sine 37.2 divided by sine 11.2. And this gets me, I round to the nearest tenth, but that rounds up to 0, so 259 for my side length. Then I want to do the same thing for my C. So I have 83.2 over sine 11.2 equals C sine 131.6. I want to multiply both sides by sine 131.6. Which gets me C equals 83.2 sine 131.6 divided by sine 11.12. Which gives me 320.3. Not on the screen. Okay. Then I have this next problem. It tells me two sides and an angle of a triangle are given. We need to determine whether the measurements produce one triangle, two triangles, or no triangle at all. If I can have one or two triangles, I need to solve it. And then I'm rounding to the nearest tenth for lengths and nearest degree for angles. So I'm going to start off with A. I'm going to draw my triangle. I have 94, 4, 25. So I have my pair for B. So I have 4 sine 94 equals 25 sine of angle A. Then I want to cross multiply to get rid of the fractions. I have 4 sine A equals 25 sine 94. I need to get the letter alone, so I divide both sides by 4. That gives me sine A equals 25 sine 94 divided by 4. A still needs to be alone, so I'm going to find the sine inverse of that. So I'm going to go rewrite that. Okay. So this is what I need to type into my calculator to find the angle for A. So, nope. Sine inverse 25 sine 94. Close the parentheses, divide by 4. What? This one gives me an error, so there is no triangle. Okay, so we're going to move on to B. I'm going to start off by drawing my triangle. Okay, once I have it set up, I can see that I have the pair of C's, so I'm going to use that to find my angle measure for A. I have 16.1 over sine of 35 equals 18.7 over sine of A. I want to cross multiply to get sine of A alone. Or not to get sine of A alone, to get rid of the fractions. Okay. Now I want to get sine of A alone, so I'm going to divide by 16.1 on both sides. I get sine of A equals 18.7 sine of 35 over 16.1. Then I need to multiply by my sine inverse to get it alone. I get A equals sine inverse of 18.7 sine 35, 16.1. Then I want to type that into my calculator. Okay, this is rounding to the nearest degree for angles, so I get A equals 42. What I need to check is to see if I have a second A, so I'm going to do 180 minus 42. Which gives me 138. And then I need to check to see if I can add 138 back to 35 and it'll still be less than 180. 138 plus 35 is 173. 173 is less than 180, so I will have a second triangle. My second triangle will have, that's A1, and then A2 will be 138. Okay, so for this first triangle, I have this being 42, and I want to finish solving that. So then my B2 is going to be 180 minus 35 minus 42. Not B2, B1. It's my first triangle. (180) minus 35 minus 42 is 103. These are all angle measures. Then I need to find my side length for B, so I have 16.1. Sine of 35 equals little b1, sine of 103. I want to multiply both sides by sine of 103 to get b1 alone. And I end up with 16.1 divided by sine of 100 times sine of 103 divided by sine 35. Which gives me 22.2. Okay. Then for my second B2, I want to do 180 minus 35 minus 138, which gives me 7. Then I'm going to plug in 7 and get my final side length. So I still have the ratio of 16.1 over sine 35. Now it's going to equal B2 over sine 7. I multiply both sides by sine 7 to get it out of the denominator, and I get B2 equals 16.1 sine 7 over sine 35. 7, not 2. Which gives me 3.4. Okay. Then I'm going to go along and solve C. So this one, draw my triangle, 63, 10, and 8.9. So I am going to solve for my angle for A first. I have 10 sine of 63 equals 8.9 sine of A. I want to cross multiply to get rid of my fractions. I have 10 sine A equals 8.9 sine of 63. I need to divide both sides by 10 to get sine of A alone. And then I need to multiply by my sine inverse to get A alone. Okay, then I want to go ahead and type this into the calculator. This gets me an angle measure, so 52 degrees. What I want to do is I want to check to see if there's going to be a second value for A as the angle. I'm going to subtract 52, which gives me 128. 128 plus 63, I'm checking to see if it's less than 180. Gives me 191, so it's not. I only have one triangle. Now that I know my A side length, I can go solve for my C. Which gives me 65. And now that I have my C angle measure, I can find my C side length. I want to get C alone, so I multiply both sides by sine of 65. And then I get it like this, so I can type this part into the calculator. And I end up with a side length, so 10.2. Okay, moving on. This one wants me to solve the triangle, and it gives me side lengths. My printer didn't print out very well. 6, 5, and 7. So I am going to use the law of cosines, and I use it with my largest side length, which is this one that didn't print out well, 7. So I have 7 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 cosine opposite the side length I have, c. Then I need to solve out my numbers. So I have 49 equals 25 plus 36. Negative 2 times 5 is negative 10 times 6 is negative 60. Then I want to combine like terms right here with the 25 and 36, not the negative 60 because it's being multiplied by the cosine. 25 plus 36 is 61. I want to subtract 61 on both sides, which gives me negative 12. Divide by negative 60. And I have negative 12 over negative 60 equals cosine c. I want to find my cosine inverse. So I have cosine inverse negative 12 divided by negative 60 equals 78 degrees. Now that I have an angle measure, I can go ahead and use the law of sines to solve for another side. I'm going to have 7 sine of 78 equals, I'll pick 5, sine of b. I just want to cross multiply to get rid of my fraction. So I have 7 sine b equals 5 sine of 78. Want to divide both sides by 7. End up with sine b equals 5 sine 78 over 7. Then I need to find the sine inverse. This gets me b equals sine inverse of 5 sine 78 over 7. Which gives me 44 degrees. Now that I have b and c, I can solve for a. I have 180 minus 78 minus 44. Which gives me 58. Okay, on number 6, I'm going to draw my triangle. I know A is 8, B is 9, C is 123. So because I have an angle in between two sides, this is going to be cosine, law of cosines. I don't know what my C side length is, so that's what I'm solving for. Equals 8 squared. Plus 9 squared minus 2 times 8 times 9 cosine 123. Because this is all on the left side of the calculator, I can go type that all, or left side of the equation, I can type that straight into the calculator. Gives me 223.4. But this is not my final answer because C is squared. So then I'm going to take the square root of that. So if I go second square root, second answer, gives me 14.94. That's a side length, so that's fine. C equals 14.9. Okay, now that I have my side length for C, I can go ahead and use law of sines to solve for A or B. So I have 14.9 over sine of 123 equals 8 over sine of A. I want to cross multiply to get rid of the fraction. Then I want to divide by 14.9 on both sides. And I end up with sine of A equals 8 sine of 123 over 14.9. I want to multiply by my sine inverse. This gets me A equals sine inverse 8 sine of 123 over 14.9. I'm going to type this into my calculator. Nope, sine inverse first. And I get, this is an angle measure, so 27. Now that I have my two of my three angles, I can subtract from 180. This is B I'm solving for. Which gives me 30. Okay, number 7 wants me to use Heron's formula to find the area of the triangle. Let me get my reference sheet out. Heron's formula is the A equals the square root of S times S minus A times S minus B times S minus C. S is 1/2 the perimeter. So the first thing I need to do here is find my perimeter. I have 1/2, 5 plus 12 plus 9. I want to type this into the calculator. Which gives me 13. And then I plug this into the formula. I have 13 times 13 minus 5 times 13 minus 12 times 13 minus 9. One thing I should say, S should always be larger than your largest side length. If it's not, you've done something wrong. Okay, then I'm going to type this into my calculator. Oops, not that button. And I want to be careful about my parentheses, because if I accidentally hit it twice, it takes me out of the square root. Or if I'm on a newer one, it'll give me an error. This gives me 20.39. It said rounded it to the nearest inch. So it's going to be 20 inches squared. Number 8 wants me to add or subtract as indicated with imaginary numbers. I'm going to start by just distributing the negative for the second part. So I have 7 plus 5 plus 2i minus 9 plus 8i. Now, I just treat this like combining like terms. I have 7 plus 5 minus 9. 7 plus 5 is 12. Minus 9 is 3. 2i plus 8i is 10i. Remember, when we're working with imaginary numbers, the real number goes in front. Okay. Then for the last page, it wants me to find the products. So I FOIL. I have 2 times negative 4, which is negative 8. 2 times negative 6, which is negative 12i. 4i times negative 4, which is negative 16i. 4i times negative 6i is negative 24i squared. I'm going to start by combining my terms in the middle. That gives me negative 28i. Over here, remember I squared equals negative 1. Negative 24 times negative 1 is positive 24. Negative 8 plus positive 24 is 16. And that's my final answer once I get it down to 2 pieces. Number 10 wants me to divide and express the result in standard form. This means I need to multiply both the top and bottom by my complex conjugate, which is 5 minus 4i. So on the top I FOIL, I have 2 times 5, which gives me 10. 2 times negative 4i, which gives me negative 8i. 3i times 5, which gives me 15i. 3i times negative 4i, which gives me negative 12i squared. On the bottom, I have 5 times 5, which is 25. 5 times negative 4, which is negative 20i. 4i times 5, which is positive 20i. And 4i times negative 4i, which is negative 16i squared. Then I want to combine like terms, so I have 10 plus 7i on the top, minus 12 times negative 1. Then on the bottom, I have 25, the 20i's cancel out, minus 16 times negative 1. On the top, I have 10 plus 7i, plus 12 now. On the bottom, I have 25 plus 16. I want to combine like terms. 10 plus 12 is 22. 25 plus 16 is 41. Then I want to split this up because when I have imaginary numbers, I split them up into the real and imaginary part and I don't leave it as one fraction. I have 22 over 41 plus 7i over 41. And if I could, I would simplify those fractions if possible. Okay. Number 11 wants me to perform the indicated operation and write the result in standard form. Normally, if this was a normal 36, I could take the square root, but I can't because of the imaginary part. It's going to be 3 times 6i. Remember, we turn the negative into an I on the outside. Over here, I have 2. Square root of normal 81 would be 9, and then I for the negative number. Then what I want to do is I want to multiply. 3 times 6 is 18. 2 times 9 is also 18. I combine like terms. I get 36i. Number 12 wants me to use Dromov's theorem. This is this one with the z to the n. So I take my exponent, I raise my radius to the exponent, and multiply it by cosine with the angle also multiplied by the exponent, and I sine also multiplied by the exponent. So my exponent here is 5, so I have square root of 2 to the 5th power times cosine 5 times 7 pi fourths plus 2 square root of 2 to the 5th power times I sine 5 times 7 pi fourths. 2 square root of 2 to the 5th power is, I'm going to do my work over here in red. I can separate it to 2 squared, and I'm going to rewrite the 2 as a 1/2 to the 5th power. Why did I write it 2 squared? It should have been 2 to the 5th. So then I have 2 to the 5th times 2 to the 5/2. If I add my exponents, I get 2 to the 15/2, which would be 7.5. So I have 2 to the 7 square root of 2. 2 to the 7 is 128. So I have 128 square root of 2. Then I have cosine of 35 pi fourths plus 128 square root of 2. This came from me doing my scratch work over here. I goes after the 8 before the square root. Sine 35 pi fourths. Then I need to find the values of 35 pi fourths. This is 2 pi, which would be 8 pi fourths. Another circle would be 16 pi fourths. Another circle would be 32 pi fourths. 1, 2, 3. I end up in the third quadrant to get to 35 pi fourths. So this would be 128 square root of 2. Cosine is negative here. So I have negative square root of 2 over 2 plus 128i square root of 2 negative square root of 2 over 2. Square root of 2 times square root of 2 is 2, divided by 2 cancels out, so I have negative 128 minus 128i.